Don't you just love an American voiceover? Hello everyone, my name is Johnathan. I'm the Head of Solution Engineering for Senseye Predictive Maintenance, a business unit within Siemens. And today we're going to be talking about how to generate maintenance confidence using AI and predictive maintenance. For today though, I want to start off with a few fundamental truths about predictive maintenance and Senseye. Then I'm going to discuss how Siemens can help you with the design, realize and optimize portion of a deployment. And then we're going to talk about a few business outcomes and hopefully get to show you a bit of the application itself. But starting off, essentially, at the core of predictive maintenance is condition monitoring. But with traditional condition monitoring, you have a specialist go around your facility, take manual measurements, then upload them to the computer, analyze them, and report back on them. And as soon as that reporting has taken place and been given to the maintenance team, that is when they enact condition-based maintenance. Essentially, predictive maintenance makes use of online condition monitoring data and gives you insight. But like any good condition monitoring engineer, it also continues to learn and get better. It learns about failure modes, failure patterns, it learns about maintenance events, and can be more specific around what is happening. It's important to understand, though, that a predictive maintenance system like Senseye is a technology. It's not a strategy. Enabling or using that information, which is provided by the technology, implements a predictive maintenance strategy in your environment. It is also not a big data problem. We're looking for very specific sets of data and highly processed, and we'll get into that a little bit later. It's often misunderstood, though, that predictive maintenance is about predicting this failure. How long before you can tell me my bearing's going to fail? And it's not actually about predicting failure, it's about predicting the need for maintenance and giving you an indication of when you should perform that maintenance. And it also doesn't replace any of your expert skill sets on site, any of your expert knowledge. It's about scaling their activities. So essentially, condition monitoring data is at the absolute core of what we do. Then, the condition-based maintenance insights are given through. With continued learning, we're able to give predictive maintenance insights. However, we do have what we call conversational PDM. This is using generative AI and language models to essentially make this information accessible to everyone. Because, and I'll touch on this a bit later, essentially, it's information. And you need to be able to give the users the information in the easiest way possible. And once we have implemented Senseye, our customers, within the first 6 to 8 months, typically benefit from the maintenance of uptime, or at least avoiding those negative downtime events. Having early indication that something meaningful is changing with enough information that you can go repair the asset when it best suits your team, when it best suits your production environment, when you have the spares. However, when maintenance teams really start to incorporate this information into their day-to-day practices, they still benefit from that early indication that something's going wrong. But for the other 95% of their assets, they don't touch. It's perfectly fine. You can see that it's in a good condition, and you don't need to induce failure by performing maintenance in some cases. So really, with more information, they can benefit from precise and correct maintenance. And that then drives the rest of the benefits, like reducing risk and operating cost. The less someone has to touch a machine, the less risk and cost there is. The Senseye application supports knowledge capture from your OT environment, your IT environment, and now from the human element, your main resource on site. And we do increase sustainability for global expansions, really because now you have less emergency transportation of spares, less consumables used, and less time spent idling while a part of your line gets repaired. One of the key factors, though, of Senseye is that it can provide predictive maintenance insight on any asset of any age, anywhere around the world, as long as we have relevant data for these assets. And we go through quite a structured process on identifying what those data sets should be for each type of asset. But we don't have a library or templates or even pre-built machine learning models for asset types or production types. We are not experts in any one industry. Really, the key factor is that Senseye treats every single asset as unique. It doesn't matter that we're monitoring thousands of electric motors or thousands of robots. The Senseye application has a one-on-one relationship with every single one. The reason that we've taken this approach is, imagine you buy 2 electric motors from the same supplier and you install them in the same facility. Well, they could be attached to the floor differently, or the structure of the floor could be different. So one could be on the ground floor on a concrete base. The other could be on a metal mezzanine platform. They could have had different maintenance interventions within their lifetime and different skill sets of maintenance people working on them. They could be subject to different temperatures, particulates, humidities. One could be inside in an air-conditioned clean room. The other could be outside, exposed to the elements. And their loaded life cycle or their day-to-day functions would be different. So when it comes to detecting the early signs of degradation in an asset, these factors and many others mean that this asset's degradation patterns will be unique. So we don't just look for a templated idea, we treat every single asset as unique. And to do that, the Senseye application requires data. More specifically, 3 forms of data. We have condition monitoring data like pressure, current, torque, vibration, temperature, speed, flow, cycle time. Really, whatever is relevant to identify a normal condition and then highlight signs of degradation within that asset. It also takes an operating context, such as speed for a variable speed application, or a recipe identifier for batch production. And then the third form is maintenance data. So the application takes in this information, and for a steady state machine, after 2 days, it builds a unique digital fingerprint of normal behavior for an asset. It's not trying to compare an asset to a brand new state or OEM specifications. It just wants to define what is normal for this asset, regardless of its age, regardless of its history, and then compares that to live data. So what is normal and what is happening now? And essentially, the application is looking for changes in behavior in the data. So we have a suite of in-house built machine learning algorithms which are looking for a range of behaviors within the data, whether that's anomalies or trends, even statistical forecasting and degradation matching. When the application spots this, though, that goes to the attention engine, which then defines an attention index score. Essentially, how concerned should you be as the user or the maintainer about this anomaly, or the trend, or the combination of both across multiple measures? Really, it helps to prioritize where you focus your attention. So, from the moment we're on board, well, after 2 days at least, we are able to provide very good online condition monitoring with operational context and diagnostic messaging. Over time, with very good feedback, the application can do statistical forecasting, which really is a look into the future to say, within the next month, when should you repair your asset by? Because afterwards, or after this point, statistically speaking, that could indicate failure. The attention index helps to prioritize where you focus your attention. You know, in a facility with 1,000, 2,000, 3,000 assets, you may have 50 or 100 cases. Which ones do you address first? Well, the attention index does that. And we have released the generative AI, which makes the information accessible to everyone. So just covering a bit more on the Gen AI and Senseye's Copilot a bit, I'm going to start off with a quote from the Siemens fearless leader. This is the beginning of a new era. In the past, we had to speak to machines in their language. With Siemens industrial copilots, we can speak to the machines in our language. And that is very true. But there's no point in implementing something if it doesn't have a use case. So we have identified this, and we do believe that generative AI is perfectly suited for predictive maintenance. So the use case is lack of data literacy. Maintenance engineers, mechanical engineers, and technicians are very good at fixing machines, but they aren't data analysts. They're not data scientists. So when you show them a graph and charts and squiggly lines, what are they supposed to do with that? Also, lost knowledge. Now, I'm sure a lot of you are getting a little bit fed up hearing of this lost knowledge, aging workforce, we're losing all of our skills. But the fact is, it is true to a certain extent. But imagine being able to capture not only your experienced technician's skill set, but every person who works in maintenance, capturing their experience, what they're working on at the time, capturing their knowledge, learning from their feedback, their interactions, from their day-to-day maintenance events. And also for global organizations, like I'm sure many of you are in, the collaboration, especially when working in different geographies, whether that's language barriers or just access to having the right information or the same information. So with generative AI and Senseye's Copilot, we do answer these. Really, the Copilot allows you to get instant answers to all of your questions. You have a place to ask So if you're unsure, if your maintenance teams don't know where to go, if they don't have a condition monitoring or a reliability background, you have somewhere to go immediately for answers. It also does retain the knowledge forever, well, at least from the moment of onboarding. So from the moment you onboard all the way through, that knowledge is stored and learned from and easily referenced. You don't have to go searching through manuals, it is there at a click of a button. And it's also easy to share this knowledge, regardless of what the native language is. This use case is especially good when you have OEM manuals, for example. Let's say they're in Swedish, but the whole team speaks Danish. What do you do then? Well, because generative AI works in all languages, it is easy to access that information really easily, very quickly, and in your language. So I want to touch on the design, realize, and optimize section. So quite often in today's market, we're coming across this approach. A company sells predictive something, typically predictive analytics, a platform which will allow you to create customized models that you can send your data science teams to, and they can implement a solution in your environment. The problem with this is it's inherently unscalable and, in my opinion, not fit for purpose. It is predictive analytics, not predictive maintenance. Wonderful platform, great visuals, but it gives you the ability to customize and create. Absolutely fine. So if we look at the workflow, from problem definition and requirements through to rollout and even post-deployment monitoring, you're looking at anywhere between 14 to 24 months per asset type. Or you could double your resource and do 2 asset types in that time. Triple it, and so on. You get the picture. This is inherently unscalable, and this only focuses on machine learning algorithms. This doesn't factor in anything to do with your infrastructure, your resources, your success criteria. This is just defining a data science approach to your problem. Senseye does not go through this. We have a very structured approach, and our thinking was really, how do you speed up a deployment and capitalize on your learnings? Taking an initial deployment on one site and scaling it through to a global organization. Essentially, design once and deploy multiple sites. So we have a very structured methodology, a step-by-step guide that comes in 5 phases. These 5 phases are scope, design, deploy, operate, and refine. And this is a step-by-step guide to investigating, implementing, and scaling predictive maintenance in your environment. And we manage this process with you. And if you let us manage this as Siemens and help with all the infrastructure, architecture, integrations, and so on, essentially what this is saying is that by week 5, your users could be trained. There will be live data from your assets, or could be live data from your assets in a system. Users are being trained, and you're starting to get value. And from there, you continue to scale out and roll out. So a much faster approach, because we don't have to worry about customizing algorithms or selecting and fine-tuning the right algorithms for your use case. What we're focusing on is making sure we have the right people, the right assets, the right infrastructure in place so that the application can do its thing. And we give this knowledge online to every single user of our application. So it's a complete user journey that we have. It is based off of over 100 years of combined condition monitoring and engineering experience. It has come from every single deployment that we've had in a full range of industries. And it really does follow these points. So the first phase that we would run through is scope. This is within the sales cycle, essentially information gathering, making sure that we're targeting the right areas, we have the right people, and we are heading towards success. So the very first phase within scope is to understand the value and benefits. So really, which areas, which assets, which production lines are going to have the highest value within a 12-month period for predictive maintenance. And when we look at value of predictive maintenance, we're looking at reductions in breakdowns, reduction or efficiencies in planned maintenance, reductions in spares usages, and even short stops. So once we've identified where we want to start, we define the objectives and constraints. We then make sure we understand who's going to be a part of the project. Do we have the right skills and resource? Do they have dedicated time for this project? And once we have all that tied in, we can give a wonderful technical proposal. Once the project starts, we go into the design phase, which starts with the asset selection. But really looking at the assets that have been selected, understanding their operational complexity and operational interdependency. We look at how these assets have been failing, what maintenance events are being carried out in them, what data do you have existing in your infrastructure that we could use? Where is that data sitting, and how are we going to get this to the cloud? From there, we go to deploy. This is really about making data move. So if there is need for additional hardware to be installed, that gets done. That we make sure the data is being captured, processed, and sent to the Senseye cloud, ready to be onboarded. In this phase, managed by Senseye and the regional Siemens colleagues, we onboard the assets, we onboard the users, and train them. And at this point, it's ready to use. So at this point, we go into the operate phase, which runs through the best practice approach on using the application, getting the most of it. So how to monitor notifications, how to best add in maintenance events, how to do daily, weekly, and monthly case reviews, as well as periodic reviews of the system. And then in the refined phase, it's about making it as good as it can possibly be. So we look at the need for additional data or higher processing of the data. We look at who is using the application. Some of our customers, they have entire teams. Every morning, they come to the stand-up ready with their notifications, and they introduce this information to the stand-up. Other customers, they have a dedicated PDM champion, one person who is responsible for distributing the information. Either approach is fine. The most important factor is it being used? Are the maintenance teams acting out this information? We look at what success has been achieved, and how do we scale that success outwards? And we also look to integrate into daily workflows, whether that's integration with your maintenance management system or even Microsoft Teams. Again, we are providing users with information, so we want this information to be where you need it. So essentially, Senseye is used by maintainers, but learns from machines and humans. But as a company, we focus on business outcomes. So looking at some of those, here is a nice list of business outcomes. At the bottom, we have avoiding potential failures, capturing maintenance activities, knowledge capture. Through the middle, we have safety KPIs, planned maintenance reduction, and avoiding overtime. And at the top, OEE improvements and sustainability. So when we engage with customers, they go, yeah, this is really good, Senseye, absolutely. We want to start off small though, 10, 15 assets for 6 months. Okay. Problem is that's their expectation. Those are the business outcomes they think they're going to be achieving and benefiting. And unfortunately, it is my job to reset their expectations to that. If you want to start off on 15, 20 assets, you will be able to avoid potential failure. You will be able to capture maintenance activity and knowledge capture using Gen AI on those 20 assets. However, increase your project size a little bit, you get more. Now you can have uptime improvements on these assets. So a little bit more of a project for at least 12 months, we can actually start to see a bit more benefit. When we start to go to a single site, but hundreds of assets, you get a massive jump in business outcomes and the benefits. Because now you're getting everything all the way to avoiding overtime. A bit more there, when you start moving on to multiple sites, you start to really affect energy efficiency and optimized resources on a much larger scale. And for a global expansion, this is where you can have everything, including sustainability and impacts on sustainability. So essentially, the application is about presenting users with the right information at the right time. It should be easy to use, easy to understand, and focus everyone's attention. So I'm going to play a recording now of the demo. We'll voice it over, but let's see if it plays. So this is the Senseye Predictive Maintenance application. Within this environment, we have a range of industrial sectors. Really, this is meant to represent multiple factory locations around the world. But for today, we're going to go into the pharmaceutical industry, where we have a range of areas or sections, and we could drill down further to get to individual lines and then assets themselves. Essentially, we want to make it as easy as possible to navigate through. But our homepage or landing page is the open cases page, and a case is generated when the application believes an asset requires attention. So you don't need teams of people manually analyzing the data. It's doing that for you. And it's presenting these cases in order of severity using a traffic light color coding system we can see at the bottom. So driving your user's attention. But if we undock the hierarchy a little bit bigger, and we're going to focus on the water recirculation pump, The first thing we see is cases. And this is the information a maintainer needs to know about this case. So first off, the Senseye Copilot is presenting the user with why it's raised this notification. There's a degradation and a rising trend on the motor current for this asset, for the water recirculation pump. We can see the evidence. The blue highlighted area shows you a trend. There is evidence there. We have a spanner symbol, which shows you where maintenance has been carried out, and it's now presenting users with possible explanations. So in this case, the Copilot is saying, could be a blocked valve or debris in the system causing the motor current to increase. The degradation and rising trend of motor current could be caused by a blocked valve or debris in the system. This can lead to increased resistance and load on the pump, causing the motor to work harder and draw more current. But then it's giving links. And we can see that this link here is for the 24th of May this year. So essentially what it's done is looked at the entire history of this asset and assets like it, and it's searching for the same behavior and saying, oh, we've seen this before, and we're going to present you with this information up front. So if we clicked on that link, we can see the attention index at work, really how much concern you should have. We can see the evidence for the previous case, increase in motor current. There's a trend for the increase in motor current there. And we have feedback. So this previous case was excellent, very helpful. That's user feedback. They did avoid a potential breakdown, and it was reasonable to open this case at the time. And the notes left there was found a blocked valve on the output. So that written feedback is now being presented to the user. So the Copilot functionality is assessing the data, assessing case feedback, and presenting the user with everything they need to know about this coming case. But we can also talk to it. So, it's a bit cut off here, unfortunately. There we go. Better there. So, first question to the Copilot is, are there any correlations in the data I should be aware of? The answer is yes. There's correlations on the measures, degradations and rising trend on the motor current. There's correlations between previous cases and correlations to work events. So it's not just time series data, it's data, all the data that it has. How do I identify the failure mode of this asset? Well, review the evidence and charts, consider historical cases, analyze recent maintenance activities and work, have a look at the possible explanations. And there we go. So quite a good list of things to go check. Next, who needs to be involved? So who needs to be involved in the repair of this asset? Well, maintenance technicians, maintenance supervisor or manager, depending on how big the work is, a reliability engineer or condition monitoring specialist, if you have one on site, your operations teams, because if you're going to repair an asset, you're going to affect production and operations, health and safety, and procurement, especially if you plan to replace any parts. And as I've said, it does work in any language. So translate this into Danish, and that's an intentional spelling mistake, by the way. And I don't speak Danish, but I've been told this is correct. So there we go. Essentially, the Copilot is making this information accessible to everybody. As an evolution of this, we are going to be able to, in a number of weeks, add in expert knowledge. This is user manuals, maintenance manuals, spare parts list, and have this referenced immediately in the Copilot by talking to it. So, thank you, ladies and gentlemen. If you do want to find out a little bit more, we'll be just outside of the door at our stand there. Thank you very much.